Section 2.3 and 2.7, Quadratic Functions and Their Zeros, Part 4. Example 5. Let's go ahead and start by finding the zeros of our quadratic function, and we're first going to use the method of factoring. So we have 2x squared minus 7x plus 3 equals 0. You can go ahead and factor now, or if you want to do the box method or another method that you're more comfortable with, go ahead and do that now. So I'm going to do the box method just real quickly for you here on the side. Our first term is 2x squared. Our last term is 3. And then our first times our last term is 6x squared. So that's 2x squared times 3. And that gives me 6x squared. So what two factors multiply to give you 6x squared, but add up to give you negative 7x? If you said negative 6x and negative 1x, then you are correct. Now let's go ahead and find the GCF, and I'm going to start with my columns. So what is the GCF of 2x squared and negative 6x? 2x. Let's move on to the next column. What is the GCF of negative 1x and 3? Now notice that in this case, the first term is negative, and that is why I'm going to pull out a negative. Okay, let's go ahead and do our rows. What in the first row, what is the GCF? X. And then again in the second row, we do have a negative in our first term, so I'm going to pull out the negative when I look for my GCF, and that is negative 3. So we are done, and this quadratic equation factors out to 2x minus 1 times x minus 3. And now we are ready to solve for our zeros. So we get x equals 1/2 and x equals 3. And so our zeros are 1/2 and 3. Now we are ready for the quadratic formula. Okay. And I'll just remind you, I know this is the third time I say it, but one more time, the quadratic formula. It is a formula you have to memorize. So I'll write it here on the side. And if you forgot my little story, you might be sick of hearing it, but here it goes one last time, and this is the third time I repeat it. The negative boy couldn't decide to go to the radical party, so he was squared and missed out on 4 awesome chicks, and the party was all over at 2 a.m. Okay, so in this case, our A is 2, our B is negative 7, and our C is 3. All we have to do now is plug it into our formula. So we have negative B, which is negative 7, plus or minus the square root of B squared, minus 4 times A, which is 2, times C, which is 3, all over 2 times A, which is 2. If we go ahead and simplify that, I'll do that for you. We get negative times a negative is a positive, so that's 7. And the radicand simplifies to 25. And the denominator is 4. And the square root of 25 is 5. So we get 2 answers. And our answers are, I'm going to split that up. So we get x is equal to 7 plus 5 over 4, or x equals 7 minus 5 over 4. And again, we're going to simplify that. So In the first part, I get 7 plus 5, which is 12, and 12 over 4, which is 3. And in the second part, we get 7 minus 5, which is 2, and 2 over 4 is 1/2. So as you can see, we get the exact same answers. Whoa, look at that. Pretty neat. Now, the last method is completing the square, which takes a little more time. And before we complete that square, I'm actually going to diverge a little bit because I want to talk about the quadratic formula. So I'm going to zoom in here for a second. And I want to talk about the radicand, or what's inside the quadratic formula. So that radicand, which is b squared minus 4ac, is actually called the discriminant. And the reason we give this part a name is because it tells us actually very important information. Okay. So let's think about what information it tells me. And I'm gonna call it D, okay? So my discriminant is gonna be D. Now, if D equals 0, that means that we no longer have this part of our quadratic formula. So we only have the negative b over 2a. That means that we're not going to get two real answers. The plus and minus go away. So if d equals 0, then we only have one real solution, or one real zero. Okay. Now, what happens if d is less than 0? Well, let's take a look at that. If the b squared, so this is where I'm looking right now. If the b squared minus 4ac is negative inside the radical, we know that in the real plane, we cannot have negatives inside the radical. But if it is negative, then that means we are now in the, does anybody know? Complex plane. So we now have imaginary solutions. Because if you remember, square root of -1 equals I. So if we have a negative inside the square root, now we're going to have an answer with an I. Now, we're still going to have this plus or minus, which means we're going to get two complex answers. So if d is less than 0, then we have two complex zeros. And I'm just going to write here, if you recall, a plus bi, that's a complex number. Okay. Now, what if, this is our last case, what if d is greater than 0? Then we have two real zeros. Obviously, if our radicand is positive, we no longer have i's and we don't have imaginary numbers, and therefore we have two real zeros, two real answers. So if you look at our example, in example 5, we have two real answers because the discriminant is positive. I will do part C in the next video, so please stay tuned. Thank you.